Large language models have significantly impacted various fields, including artificial creativity. However, these models lack intentionality and a creative process. To address this limitation, the authors introduce creative beam search, which combines diverse beam search and LLM-as-a-Judge to generate and validate responses. This approach simulates response generation through diverse beam search, producing a diverse set of possible solutions, followed by a self-evaluation phase to select the final output. The authors highlight the limitations of current large language models in terms of creativity, noting their lack of intentionality and consciousness. They review the relationship between LLMs and creativity, discussing various methods to enhance their creative output, such as fine-tuning, zero-shot settings, and reinforcement learning from human feedback. The paper also provides an overview of beam search, a text generation strategy that maintains multiple hypotheses at each time step and chooses the hypothesis with the highest probability under the model. However, beam search often focuses on a single highly valued beam, resulting in final candidates that are minor variations of a single sequence. Diverse beam search is proposed as a solution to overcome this issue, generating a more diverse set of possible solutions. The authors evaluate their creative beam search method through a qualitative assessment study, finding that end users prefer their approach and that it provides better solutions than diverse beam search on average. The paper is structured to first review the relationship between LLMs and creativity, introduce the key concepts behind creative beam search, detail the proposed method, present the qualitative experiment results, discuss the findings, and conclude with final remarks. This research paper introduces a novel method called creative beam search, CBS, which aims to enhance creativity and diversity in text generation by pre-trained language models. The process consists of two main steps: response generation and response validation. In the response generation phase, diverse beam search, DBS, is utilized to generate a set of K-candidate solutions from the pre-trained language model. DBS encourages diversity across groups through a penalty term that discourages the selection of tokens already chosen in other groups at the same step. This method simulates the creativity-relevant skills and knowledge required for domain-specific tasks, as outlined in the componential model of creativity proposed by Amabile, 1983. The response validation phase leverages the evaluative capabilities of recent generative models, such as LLM-as-a-Judge prompting, to assess the quality and appropriateness of the generated responses. This involves creating K different prompts by rotating the top K candidates and aggregating their votes to select the best candidate. In the event of a tie, the initial order of the candidates, as determined by the DBS score, is considered. The paper also discusses various other approaches, including the use of LLM-as-a-Judge for evaluating responses, enforcing constraints over the output, and substituting the likelihood with a self-evaluation scheme. These techniques have been shown to align with human evaluations and improve the overall performance of the system. The experimental setup for creative beam search, CBS, involves utilizing the Llama 2 language model, a 7B variant with RLHF tuning, and allocating a beam budget of 8, divided into single-item groups. To counterbalance the likelihood score, a diversity penalty is scaled by a factor of 10. The top K equals 4 solutions are retained for evaluation, and the DBS step employs a specific prompt for response generation and validation. Repeated K equals 4 times to alter candidate positions. Model outputs are limited to 256 new tokens, and a greedy decoding strategy is employed. In a qualitative evaluation, 31 graduate students in computer science input prompts and chose between CBS and standard output. The presentation order of the two solutions was randomized, and users could indicate if the outputs were too similar to differentiate. Results show that CBS was preferred 45% of the time, with a significant margin over the standard output. However, in about 1/4 of the cases, the responses were too similar to make a choice, suggesting that despite the diversity penalty and self-evaluation step, CBS output does not deviate significantly from standard sampling. Notably, the candidate selected during the self-assessment step provides insights into the model's ability to evaluate its own creativity. While CBS demonstrates improved creativity, the results also highlight the limitations of the approach, indicating that further refinement is necessary to achieve more distinct outputs. The authors present a qualitative assessment of their creative beam search (CBS) approach, benchmarking it against standard sampling methods and diverse beam search (DBS). The results, as shown in Table 1, demonstrate a significant preference for CBS over standard sampling methods, with a substantial proportion of users favoring CBS when its output diverges from DBS output. Figure 3 provides a more granular analysis of user preferences, revealing that CBS outperforms DBS in terms of perceived creativity and diversity. The CBS approach is designed to enhance the diversity of generated text by introducing a novel scoring function that rewards novel and coherent responses. This scoring function is based on a combination of likelihood, fluency, and novelty metrics, which are weighted to prioritize creative outputs. In contrast, standard sampling methods rely solely on likelihood-based scoring, while DBS incorporates a diversity-promoting component. The qualitative assessment involves a user study, where participants are presented with text generations from CBS, DBS, and standard sampling methods. The results show that CBS achieves a higher user satisfaction rate compared to standard sampling methods, with 63% of users preferring CBS when its output differs from DBS. Furthermore, CBS is perceived as more creative and diverse than DBS, with 71% of users rating CBS higher in terms of creativity and 65% rating it higher in terms of diversity. These findings suggest that the CBS approach can effectively promote creative and diverse text generation, outperforming existing methods in terms of user satisfaction and perceived quality. The results have significant implications for natural language processing applications, such as language translation, dialogue systems, and content generation. Recent advancements in large language models have showcased their capabilities in generating coherent and meaningful text. However, a significant challenge remains: creativity and diversity in their output. The concept of bits of grass refers to the model's ability to generate diverse and creative responses, an area where large language models still struggle. To assess creativity, researchers employ alternative uses tests, which evaluate a model's ability to generate novel uses for common objects. This test has been applied to various models, including GPT-3 and GPT-4, with varying degrees of success. One promising approach to improving creativity is leveraging human feedback through reinforcement learning. This involves training the model to optimize its output based on human evaluations, encouraging more innovative and diverse responses. By integrating human feedback, large language models can potentially overcome their creative limitations and generate more novel and useful outputs. While these advancements hold significant potential, it is essential to acknowledge the risks associated with large language models. As they become increasingly sophisticated, concerns arise regarding their potential misuse, such as generating disinformation or perpetuating biases. Therefore, it is crucial to develop and implement safeguards to mitigate these risks and ensure responsible development and deployment of these models. The future of large language models depends on striking a balance between creativity and control, harnessing their potential while mitigating their risks. Ongoing research aims to refine these models, exploring new methodologies and techniques to enhance their creative capabilities while ensuring their safe and responsible use. Building upon recent advancements in self-rewarding language models, this research paper draws inspiration from Yuan et al.'s 2024 work on ArXiv, which introduced the concept of self-rewarding language models that learn to generate text by predicting their own rewards. The authors also cite Jung et al.'s 2023 paper, which proposed the MT Bench and Chatbot Arena frameworks for evaluating large language models as judges. The authors aim to further explore the capabilities of self-rewarding language models in generating coherent and informative text. They formulate the problem as a reinforcement learning task, where the language model learns to generate text that maximizes a reward function. This reward function is designed to encourage the model to produce text that is both fluent and relevant to the input prompt. The authors propose a novel algorithm that leverages the strengths of self-rewarding language models and reinforcement learning. This algorithm consists of two main components: a language model that generates text and a reward predictor that estimates the reward function. The language model is trained using a combination of maximum likelihood estimation and policy gradient methods, while the reward predictor is trained using a supervised learning approach. Experimental results show that their approach significantly outperforms existing methods in terms of generating coherent and informative text. The authors evaluate their approach on a range of benchmarks, including the MT-Bench and Chatbot Arena datasets. They provide an in-depth analysis of the results, highlighting the strengths and limitations of their approach. Future work involves exploring ways to improve the robustness and generalizability of self-rewarding language models, as well as applying these models to real-world applications such as chatbots and language translation systems.